IBM blockchain works and how the Ethereum is worked. Yeah. So I think the next I would like to share with you about my recap, yeah, or maybe my journey with the Ethereum. Yeah. So I think because yeah, I understand that maybe if we using the IBM blockchain platform is mostly like it's more private blockchain platform. Yeah. So if you want to explore more deep, I think you need to have some extra time and also extra resource to learn about it. Yeah. So I think the IBM platform exploration I will share to you next week, and today I would like to share with you about the Ethereum platform. Yeah, for you. So what I found it actually the Ethereum is one of the we can call as a platform or application, yeah, on top of the hyperledgers here. So basically the Ethereum try to build the blockchain their own blockchain architecture, and then using concept of the hyperledger, and then they bring the tools and then the environment to develop our own application or smart contract. Yeah, so that's why I think, yeah, I agree that the larger community in the world is actually is the Ethereum. Yeah, so especially for many purposes. Yeah, so yeah, so that's why if we discuss about the blockchain, the Ethereum will be mostly captured in the presentation or maybe in the explanation. So, and the Ethereum is very unique, yeah, because they start, or they know first is not as a platform actually. So actually it's like Bitcoin. They know as cryptocurrencies application actually, yeah. And because they use a lot, and then they develop, and then they push further into as platform, not only just a cryptocurrencies applications. Yeah, so that's the good one of the Ethereum. I think beside the Ethereum, we can found many applications, especially in the cryptocurrency, that we can see about the platform. Yeah. So I think the Ethereum blockchain, because start as a cryptocurrencies application in the early stage, so essentially it's transaction-based state machines here. So the typical of the Ethereum is especially for transaction-based here. So this is like a blockchain platform for transactional system. Yeah. So transactional system is not only just for currencies or similar with that. Yeah, but it can be used for the business processes that's mostly use transactional based. Yeah, like enterprise resource planning, supply chains management, and similar with that. I think it can be used using the Ethereum. In case of this, maybe like the hospital, and then some of the information system like us in university, I think it's potential to use the platform from the Ethereum, we if we consider about the type of the Ethereum blockchain itself, yeah, which is a transaction-based state machines. Yeah. So actually, what the main of the transaction-based state machine is, if we discuss about the in the computer side or in the computer science view, so the state machine refer to something that will read a series of input, and based on those input will transition to a new state. Yeah, you need to. I think you still remember that the blockchain is like the group of chains here that related each others. If it will be triggered with several input, and then will be produced, and then will be develop a new state. Yeah, so that we call new block. Yeah, so that's why will be this state machine is very important to understand about the concept of it. Yeah. So yeah, this is the explanation why the Ethereum is very is appropriate for the transactional base. Yeah. So if we illustrate into the picture or diagram, I think you can see the slide that, for example, if we start from the state of A, so it's mean like if we have the input, and then it will be trigger another state to react, and then to generate the output for become the input for another state. Yeah, so it's mean like we make some chain reaction, yeah, on the every node that we involve with the network. Yeah, so that will be the main of the state machines. Yeah. So in here, so actually we will familiar what we call the genesis state. Yeah. So the genesis state actually is like the initiation of state that gives some some trigger to follow by the another state. Yeah. So of course, the transition between the genesis into the state one and then go to the state two will be transitioned by the transaction that occurs in the smart contract here. So you can see that one that the state will be triggering by the transaction that occurs or happen on the smart contract. Yeah. So that will be of course, if the system or the application or which is the smart contract is produced in every time and every processes, it's mean the chain reaction between the state will be infinite. Yeah, it will be happen. So it will be no end, I think, and it will be even the end will be in the end of the system. I think that will be that one. Yeah. So that's why the genesis state will be the basis of the to explain about the blockchains. Yeah. And of course, because the state itself will be will be formed into the block, yeah, especially to store the data that we need to consider to save on the blockchains, yeah, on the data blocks. Yeah. So that's why we will have a block one, block two, and etc. That will be actually it it represent the transaction, yeah, that we already discussed earlier. And then the transaction itself will be stored inside the block, and then we will have a headers. Yeah. So you can see that all the block will have a header. Yeah. To do that, to administrate the data block. Yeah. So, but unfortunately, sometimes when we do some genesis state, we make some chain reaction that not always linear. Yeah, somehow it make a parallel and become a fork. Yeah, so it can be happen. The unused state is occurs in the transition. So we need to consider about it, and then we need to solve this problem actually in the blockchain concept. Yeah. So how to avoid that the fraud is not happen, and then we can have the data block that consistently work until the end of the transaction, of course. Yeah. So yeah, the fork it occurs because we generate a multiple path. Yeah. And then we want to avoid fork, but because they disrupt the system and force people to choose which chain they believe in. Yeah. So that also the main consideration why the fork is occurs in here. Yeah. So yeah, based on this explanation, I think one of the challenge on the blockchain algorithm is how we minimize the occurrence of the forks. Yeah. So that's why the Ethereum have their own mechanism to respond about this issue. Yeah. And then we also have this issue we call a goose, yeah, a greedy, devious, observe subtree. Yeah, and the goose protocol say we must pick the path that has had the most computation done upon it. Yeah, so it's mean we need to like in the network. I think maybe in the network, if we have a multiple node, our decision is how choose the shortest path of the node, yeah, to transmit the data. But in here, the main consideration is about the which node that already have the computation has done, and then we can choose that node for continue the data blocks change. Yeah, so that would be the challenge. Yeah, so I think same with the Genesis state, we also have the Genesis block in here, and then we will consider about the computation has done. Yeah, it's mean that will be presenting by the square that in the black color in here. Yeah, so the what the meaning of the block that have a computation done, because if the computation done, actually they will be produce a new block. So you can see somehow the fork in here is only single fork, and it's mean if we found that it's only single fork, it's mean the computation is not done because not resulting another node in here. Yeah, but if we go there in the down of the diagram, we can see that the fork is already resulting in another fork, but unfortunately the fork will be n because there is no resulting another forks, and etc. So in here, actually the Genesis block will be generated the canonical blockchains. Yeah, the canonical blockchain is the form of the blockchain that ideal to we to have, yeah, to in the blockchain, because it's all the computation is done, and can make a new block for the data block that will be stored in here. So actually in the Ethereum, like one of you that already make some some user in there, yeah, create a user in the Ethereum. Actually in the Ethereum we have a two type of account. Yeah, the first is the externally owned account. Yeah, which is controlled by private key and have no code associated with them. Yeah, and then we have also the contract account. Yeah, which are controlled by their contract code and have code associated with them. Yeah, so we have the two type of the account. Yeah, the first using the private key, yeah, like we have a username and etc. And in here the contract account is mostly like have a contract, yeah, contract detail on the account. Yeah, so it will be reflected by the contract account itself, and then depend on the detail of the contract itself. Yeah, and yeah, when we need to consider actually when we have the externally owned account, then when they have a transaction will be used by, so because the external owned account is the owner of the Genesis state or Genesis blockchain, so it's mean they will initiate the transaction. Yeah, so the transaction set in motion by an externally owned account in years. Yeah, he have the private key, and then he will make or execute a transaction, and then it will be used by the contract account that involved in the smart contract, and then will be do some internal transaction in here. Yeah, and then yeah, of course it will be responded by another contract account and etc. Yeah, so that will be important. So the most important in here is the transaction is only can initiate by the own account and the externally owned account that have the private key. The contract account is cannot cannot initiate the transaction. So that would be the important things. So if the externally owned account do some transaction and then there is no contract account involved, it's mean like that the blockchain is not made. Yeah, it cannot be cannot be processed. Yeah, so that also the important things. Yeah. So in the Ethereum blockchains, the externally owned account, because is used for the public blockchain, it can be can use in the same blockchains. Yeah, to initiate together. Yeah, so It's mean like the transaction is not only owned by one account, one externally owned account, yeah, but also can made by several user in here that have the private key. Yeah. So it's mean like if you want to initiate using Ethereum, actually you and then you can invite your friend to initiate the transaction together. Yeah. So that's why the Ethereum blockchain is called as public blockchain. Yeah. And then we can invite a contract account or a contract user to involve in the process of the transaction. Yeah. So that would be another case. Yeah. But what I want to share with you that why the Ethereum blockchain is called as public blockchain, because they can initiate by several externally owned account. Yeah. So that's not only just a public that can be access everyone. That's a different meaning. But the most important thing is the transaction is can initiate by several externally owned account. Yeah. So that would be the difference. And what the important things is if when we have this one, the account state that represent by the externally owned account and the contract account, actually have this the four attribute. Yeah, the first is nonce. Yeah, so this is the if the account is an externally owned account, this number represent the number of transactions sent from the account address. If the account is contract account, the nonce is the number of contract created by the account. So that will be the difference the between the externally owned account and contract account in the nonce. Yeah. And the balance is the number of way owned by this address, and they are 1e plus 18 way per ethers. Yeah. So that will be the balance that will be calculated into the Ethereum account. Yeah. And then we also have the storage root. This is a hash of the root node of Marco Patricia tree. And then we will later on explain about it. This tree encode the hash of the storage content of this account and is empty by default. Yeah. And then we also have the code hash. Yeah. The hash is very important because the hash is will be used in the EVM, the Ethereum virtual machine, of this account. Yeah, for a contract account, this code that gets hashed on the stores as the code hash. Yeah, for externally owned account, the code hash field is the hash of the empty string. Yeah, so that will be different of the code hash. Yeah. So when we see this one, so every single account will be have this attribute. Yeah, they will have the nonce, they have a balance, it will be have a code hash and also a storage root. Yeah, it's same with the contract account, but then the inside the nonce will be different. Yeah, it will be depend on the externally owned account on the of our contract account itself. Yeah. And we also have a world state. Yeah, the world state is depend on the Markov tree. Yeah, Markov tree is type of binary tree composed of set of nodes. Yeah, so we make a three node architecture in here to explain about a large number of leaf node at the bottom of the tree that contain the underlying data. Yeah, and then we also have a set of intermediate node where each node is the hash of its two child node. Yeah. And then we also have a single root node also formed from the hash of its two child node, yeah, representing the top of the tree. Yeah. So that will be the Merkle tree about it. So the Merkle tree form will be like this one. Yeah. So it would be like a code and some things that represent the hash, and then we will have some node and leaf node that showing the Merkle tree structures. Yeah. And the most important thing is the data at the bottom of the tree is generated by splitting the data that we want to store into the chunk. Yeah. Yeah, and then the chunk will be split into the bucket, and then taking the hash of each bucket and repeating the same process until the number of hashes remaining become only one, the root hash. Yeah, so it will be become the root hash in here. Yeah, so that will be the integrity concept of the blockchain will be occurs in here. Yeah. And this tree is required to have a key for every value stored inside it. Yeah? And beginning from the root node of the tree, the key should tell you which child node to follow to get to the corresponding value, which is stored in the leaf node. Yeah. In Ethereum case, the key value mapping from the state tree is between addresses and their associate account, including the balance, the nonce, code hash, and storage root for each account. And where the storage root is itself a tree, yeah. So that will be the nice one. So when we break down into more detail, the form of the tree, it will be like this one, yeah. So it will be, we will have the state root in here, and then we will have, in every leaf we have a nonce and the balance, the code hash and storage root, and then we will have another tree inside the storage root in here. Yeah. So that will be giving to how the data structure on the blockchain will be stored in this case. Yeah. And so that's why in the every block we will have these structures. Yeah. So we will have a block headers, and then we will have a parent hash, we have a nonce. We also store the timestamp, the owners hash, yeah, the beneficiary, the logs bloom, difficulty, extray data. Difficulty is like the level of difficulty when we try to get the mining. Yeah. So the mining result. Yeah. So that's why if you see like the Ethereum mining or the Bitcoin mining, the difficulty will be in the factors to calculate with the fee that we will have. Yeah. And the number, the cash limit, cash use, and other things. Yeah. And the most important thing is we have a state root in here. We have also the transaction root, and we will have a receive root in here too. Yeah. So that will be the good one. Yeah. And if we see this as a one package, yeah, so we will have a full archive node synchronizes the blockchain by downloading the full chain, yeah, from the genesis block to the current head block, yeah, executing all the transaction contained within, yeah. It's mean if we want to involved in the Ethereum blockchain processes. So it's mean we will downloading the full chains here. So it's mean we also have we will become the ledgers too, and then we store the information from the previous transaction, and then that's make the transaction on the blockchain become transparent, and then all the node that involved is have the information. And instead of downloading and storing the full chain and executing all of the transaction, Lightnode download only the chain of headers from the Genesis block to the current head, yeah, without executing any transaction or retrieving any associated state. Yeah, it's mean that we download all the data. It's mean like only the result. Yeah, not we try to process all the process from the beginning. Yeah, so I think if we process all the beginning, I think it will be very impossible. Yeah, in the matter of time and also the computation processes. So that's why we will have this one. Yeah, so it's mean if of course sometimes the block headers is come the error or something because it's not recognized by the another node. So it's mean we will have this error. Yeah, so that will be also very important. Yeah. So the Markov proof consists of a chunk of data to be verified and it has, yeah, and then the root hash of the tree and the branch, yeah. The branch is mean all of the partner hashes going up along the path from the chunk to the root, yeah. So that would be very important because it is like I call like a DNA tree. Yeah. It will be reflected the history of the transaction, also reflected all the thing of the blockchains, yeah. So that would be very important. So that's why the good one is actually we can have this appropriate tree. Yeah? So there is no error in here. but the most important thing is all the tree of the root is we can capture in the good manners, yeah, of the things, yeah. So actually that will be how the Ethereum works, yeah. So what we can use is only the application or the interface of the Ethereum itself, yeah. So all the processes will be run in the Ethereum virtual machine, or will be called the EVM. Yeah. The EVM is actually implementing the Turing complete virtual machines. Yeah, this is like using the Turing concept on the virtual machine as a state machine. Yeah, the only limitation of the EVM has that the typical Turing complete machine does not is that the EVM is intrinsically bound by gas. Yeah, thus the total amount of computation that can be done is limited by the amount of data that we provided. Yeah, so that also will be the challenge. Yeah. So yeah, this is like the illustration about about the how the EVM will be works. Yeah, and then actually the EVM architecture will be like this one. So we have a volatile layers in here that will be have the memory, and then the stack in here, yeah, and then will be do some call for data loaded, yeah, and then the memory will be keep the addresses, yeah, and then other things, and then the of course the storage and the code will be in the non volatile layers that will be become the storage of the transaction that occur on the blockchain processes. Yeah, so that will be the EVM works. And the EVM is not run in the first time, but before they do some computation, the processor will be make sure that all the information is available and valid. It means all the nodes that involved in the blockchain process will be ready. So that's why the system will be collected the system state, yeah, the remaining of the computation, yeah, and then the address of the account that own the code that executing. So we try to list the address that the computation node is ready for do some computation together with us, for example, and then the address of the sender of the transaction, and then the address of the account that caused the code to execute, yeah, and then the price, and then where is the input data for the execution, and then the value, and then the what the machine, yeah, code that to be execute, the algorithm that we want to use, and then the block header of the current block, and depth of the present message call or contract creation stack, yeah, will be checked by the uh, uh, genesis state, yeah, especially. And of course, the state of the execution will be like this one. That is, the stack will be 0, the memory is not working, not yet, yeah, and the storage is available. There is no still 0 in every processes. So the 0 in here actually is show that the computation node is ready for do some computation that we need to do, yeah. And then the EVM will be execute the transaction, yeah, recursively, and then do some system state, yeah, and then the machine state for each loop, and then the system state is simply Ethereum global state, yeah. So will be connected to the Ethereum platform, and then we can do that one. So you can imagine that actually we like just let the Ethereum architecture or infrastructure work, and then we just store the computation, and then the machine state will be comprised of some of the information, yeah. So from the availability of the data, program counter, memory contents, active number of word in memory, and also stack content, yeah, that related with the processes, of course, yeah. And in the end of the each loop, we have three possibilities here. I think it will be also related with the occurrence of fork, yeah, that happen state machine. And the first possibility is the machine reach an exceptional state. Yeah, so exceptional state is also include the fork states. Yeah, I think. Yeah, so maybe it can be an insufficient data, invalid instruction, maybe in the pet program in here, and insufficient stack item. Yeah, and overflow. Maybe we do some jump or invalid destination, and it make the chain reaction of the blockchain must be halted, and we need to change. Yeah, and then we need to any change that happen before the event happen, it will be discharged. Yeah, so that is very important. And the sequence continue to process into the next loop. Yeah, after the problem is solved, the continue will be the sequence will be continue until the next loop. Yeah, and then the machine reach a control halt. Yeah, the end of the execution processes. So it's mean there is no execution, the next execution that needed to run, because it already done. Yeah, in the end of the process of the execution processes. Yeah, so there is a three possibilities in the end of the loop. Yeah, when of course if we see when the process is stopped, we need to consider, and then we need to check deeply, is there any three possibilities of these processes. And of course it's that's why the blockchain is become some have some complexity, because when creating the block, the concept of block itself is difficult. Yeah, and the algorithm that give meaning to block difficulty is called proof of work. Yeah, so it's mean when we want to create a data block that consists of header and transaction, and then we store into the another node and etc., it actually is the process is actually is difficult. Yeah, and that's why we have a difficulty factor in here. So it will be more, if more difficult, it's mean the algorithm will say that the fee will be more high than normal difficulties, something like that. So that's why the proof of work is very important, because this is the algorithm that will explain how the difficulty will be accepted and then will be recognized as result of the blockchain processes. And then the Ethereum proof of work algorithm, they have the algorithm itself. It's called ETHASH, yeah? Actually known as Taker Hashimoto algorithm. I think you already know, but the Hashimoto is one of the founder of the blockchain algorithms, and the algorithm will be defined where M is the mixed hash and then N is nonce. Its N is the new block's header, yeah, excluding the nonce and the mixed hash component, which have to be computed. Its N is the name of the block headers, and D is the DAG, which is a large data set. Yeah, so that will be the algorithm that we need to define as the block difficulties. Yeah, so that will be the interesting. Yeah, and then the proof of work can be shown by this diagram. Yeah, actually. Yeah, so if we have the blockchains, and then it will be have some computation to see about the hash power, and then the probability of the hash power will be have some of the formula in here. Yeah, so that will be the how the algorithm of the proof of work is very is work hard for these processes. So that's why in the computer science in our area, the discovery and then the research on the proof of work algorithm, especially on the process of the blockchain, is still challenging, and become one of the challenge on the blockchain's research today. So yeah, that's it. You can see the rest maybe in the more detailed explanation on this link. Yeah, so hopefully this is give you some my exploration about the Ethereum, how the Ethereum works, but in the computer science point of view. Yeah, of course. Yeah, to show about it. So I just want to give you some clue, and then also the trigger if you want to, if you explore the platform like the Ethereum or the IPM blockchain, maybe you can push the knowledge on the computer science view, and then you see which one, which part of the platform that do some computation processes that related with our field, and then we can identify which one is still challenging, and then which one is the part that have some the big potential for to research in here. Yeah, it's not only just about build some application or smart contract, yeah, on top of the Ethereum. Yeah, so that also one thing, I think. But another things in the very deep is about the about the algorithm that for example, like in the discussion about the block difficulties, and maybe about the how we created the data block, and how we arrange the machine state processes, how we handle the possibility of the end of the loop, and etc. So that would be the good one. Yeah. Okay. So that my update for you in the Ethereum blockchain, how the Ethereum blockchain platform work. Yeah. So I think if you want to learn about how the Ethereum works in the application level, I think a lot of information in the internet you can learn by yourself. Yeah. But my suggestion for you, you need to you need to more explore, yeah, about it. And then even I know the blockchain is still, for us, for me itself, is I think a lot of things still need to be learned. But I think if we go through in there, and then we find out some, some point to discuss, I think in that point too we will have knowledge about the blockchain, about the some of the inside the blockchain, yeah, that we need to consider. Yeah. Okay. I think that's it for the explanation for the